Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई कि रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज टॉपिक रे हमें सोल जेल प्रोसेस विषय रे पढ़िबा व्हिच इज अ बॉटम अप अप्रोच फॉर द सिंथेसाइजेशन ऑफ nanostructure materials and it is in use since late 1800s means more than 200 years ago its use has been started but however the modern soul gel technique has started around the year 1970. Okay, so it is an example of liquid phase synthesization and here a soul means a colloidal or molecular suspension of solid particles or ions in a solvent and a gel means a semi-rigid mass that forms when the solvent from the soul begins to evaporate and the particles or ions left behind will begin to join together in a continuous network. Okay, so soul gel is a multi-step chemical solution process, that is a wet chemical technique which is widely used recently in the field of material science and also ceramic engineering in order to make ceramic and glass materials in the form of thin films, fibers or powders. Okay, so this soul gel process generally starts with the mixing of metal alkoxides or salts in water or in a suitable solvent and in most cases that is your alcohol at some ambient or slightly elevated temperatures. Okay, thus the metal alkoxides and the metal chlorides are typical precursors in this process which undergo a process known as your hydrolysis and polycondensation reactions. Okay, so the most widely used are like tetramethoxysilane, that is TMOS, and tetraethoxysilanes, that is TEOS, which form silica gels. Okay, further alkoxides are immiscible in water, that means whenever alkoxides are mixed with water they will not form any homogeneous mixture, right? So they are organometallic precursors for silica, aluminum, titanium, zirconium and many others. Okay, so in the process metal oxo or metal hydroxo polymers are actually formed. Okay, so in this soul gel process it is very important to control the pH value of the starting solution in order to avoid the precipitation as well as to form homogeneous gel which can be achieved by the addition of base or acidic solutions. Okay, so we can maintain the pH value by adding the base or acidic solutions. Now the organic compounds with hydrophilic functional groups in small molecules such as citric acid, succinic acid, oxalic acid, then tartaric acid, etc. along with polymers, for example polyacrylic acid and polyvinyl pyrrolidone can be used with metal ion sources in order to form the soul as well as to control the particle size and uniformity of the products. Okay, so here a catalyst is used to start the reaction and control the pH of the solution, and this soul gel formation actually occurs in 4 stages, which is number 1 hydrolysis, then condensation, then growth of particles and finally agglomeration of the particles. So these 4 stages are now discussed in detail. So number 1 is hydrolysis. So here addition of water replaces the alkoxy groups, that is OR, with hydroxyl groups, that is OH. So this hydrolysis occurs by the attack of oxygen on silicon atoms in the silica gel. Okay, so a catalyst such as HCl, that is hydrochloric acid, and NH3, that is ammonia, accelerates the hydrolysis process. Okay, so hydrolysis continues until all OR groups are replaced by the OH groups, and subsequent condensation involving silanol groups, that is SiOH, produced siloxane bonds, that is SiOSi, along with alcohol and water. Now the second stage is the condensation. So the polymerization to form the siloxane bond occurs by either a water producing or alcohol producing condensation reaction, and this condensation reaction will finally results in the formation of monomer, dimer, then cyclic tetramer and other higher order rings. Okay, further the hydrolysis rate is influenced by the pH, as we have read earlier, along with the reagent concentration and H2O or Si molar ratio. Along with that, aging and drying are also important steps. Okay, so by controlling these factors, the structure and properties of the sol gel derived inorganic networks can be varied. Okay, now the third stage is the growth, and the fourth stage is the agglomeration. So the growth and agglomeration, so we have here, with the increase in the number of siloxane bonds, the molecules aggregate in the solution where they form a network, right? And then a gel is formed upon drying the solution. Okay, so here the water and alcohol are driven off and the network will shrink. So for pH value greater than 7 and H2O or Si value ranging from 7 to 5, we will have spherical nanoparticles. Okay, and the reactions involved are as follows. Okay, now for pH value greater than 7, silica is more soluble and silica particles grow in size. Okay, so the growth of the particles stops when the difference in the solubility between the smallest and the largest particles become indistinguishable. Okay, so higher temperatures will result in the formation of larger particles, right? Now let us see what are the advantages of this sol gel technique. So number one, sol gel method of thin film deposition is a very cheap, means less costly, and here low temperature technique is actually used. Okay, so it requires not much higher temperature, along with fine control on the chemical composition of the product. Then next point, it is able to produce high purity products because the organometallic precursor of the desired ceramic oxides can be mixed and dissolved in a specified solvent and further hydrolyzed into a sol, okay, and subsequently a gel. Okay, next point, by this process we can get a low temperature high density glass without high temperature recrystallization. Okay, next one, smaller particle size and morphological control in the powder synthesis. Okay, so this is another advantage. Then it can produce thin bond coating in order to provide excellent adhesion between the metallic substrate and the top coat. Okay, and this process is able to coat onto large or even complex shape objects. Okay, then sol gel process can produce thick coating in order to provide corrosion protection performance, and this process can have low temperature sintering capability, usually in the range 200 to 600 degrees Celsius. Then the sol gel process is a versatile one, and it can produce aerogels, aerogels, ceramic materials, then nanopowders, nanorods, and nanostructured thin films, etc. Okay, so these are the advantages. Now let us see what are the disadvantages of the sol gel technique. So first point, the cost of the raw materials, that is your chemicals, may be high as compared to the mineral based metal ion sources. The next one is the product should contain high carbon content when organic reagents are used in the preparative steps, and this would inhibit densification during the sintering process. Then next one, there is often a large volume shrinkage and cracking during the drying process due to the generation of large capillary stresses. Then actually the sol gel process, here it is very difficult to avoid the residual porosity and also the OH groups. Okay, and being a multi-step process, here it required close monitoring. Okay, now finally the process is not very clean and it contains undesired atoms, molecules, ions, etc. So this deteriorates the electrical and optical properties of the deposited material. Now finally let us see what are the applications of this sol gel process. So number one, it has been extensively used for the formation of coatings on window glass. Then it can be used to produce powders and fibers. Then sol gel technique can be used to deposit films and coatings on a range of different surfaces, enabling a flexibility which is not available in many vapor phase methods. Okay, then it is used in case of drug delivery systems. Okay, so this is a very important application. Then in making the UV, that is ultraviolet protection gels, then for producing lubricants and scratch free paints, and finally in the development of new fire retardant materials. Okay, so this is what I have taken from one book about the sol gel process, but however it has not given any single schematic diagram. Okay, so I have taken the same thing from another book. Okay, the sol gel process or sol gel technique. Here it has also described in detail. Okay, along with the four stages that we have seen, that is your hydrolysis, then condensation, then growth and agglomeration, which has been described in schematic diagram. Okay, the sol gel process. Then thereafter it has also described how the sol is being prepared. Okay, so this is the sol preparation, then this is the gel formation. Further it has given about the spray coating, then annealing of the film and formation of the required film. Okay, thereafter it has given some valuable points about the advantages and limitations of the sol gel technique. So I advise you to read from this book also and make your note by combining from both the books. Okay, thank you.